Hi dear students, in this video we are discussing the questions from the chapter Atomic Structure of +1 syllabus which were asked in the previous year's Neet exams from the year 2020 to 2024. You please listen. Question number 1. The number of protons, neutrons and electrons in lutetium-71, 175 respectively are option number 1 175, 101 and 71, option number 2 71, 104 and 71, option number 3 104, 71 and 71, option number 4 71, 71 and 104. See, this is a general representation of an atom. Here Z represents the atomic number which is equal to number of protons present inside the nucleus, which is also equal to number of electrons present outside the nucleus in the case of a neutral atom. And n is a mass number. Mass number is equal to number of neutrons plus number of protons. Here the atom given is lutetium-71, 175. Here atomic number is equal to 71. Therefore number of protons is equal to 71. Number of electrons is also equal to 71 because it is a neutral atom. Here mass number is 175. That is neutron plus proton is equal to 175. Therefore number of neutrons is equal to 175 minus number of protons, that is equal to 104. So this element contains 71 protons, 104 neutrons and 71 electrons. So here the answer is option number 2. Now question number 2. The number of angular nodes and radial nodes in 3s orbital are option number 1 0 and 2 respectively, option number 2 1 and 0 respectively, option number 3 3 and 0 respectively, option number 4 0 and 1 respectively. Listen, angular node is a plane that passes through an orbital that is located in between two maximum electron densities where there is 0 electron density. That is, for p orbital, this is a plane passing in between two maximum electron densities where psi square is equal to 0 or electron density is equal to 0. So this is angular node of p orbital. Number of angular nodes in an orbital is equal to its L value. L value means its azimuthal quantum number value. Therefore number of angular nodes in 3s orbital is equal to 0. Because for an s orbital, its azimuthal quantum number value L is equal to 0. While radial node is defined as the spherical shell inside an orbital where there is 0 electron density or psi square is equal to 0. For example, for 2s orbital, this is a spherical region inside this orbital where psi square is equal to 0 or electron density is equal to 0. So this is a radial node of 2s orbital. While 1s orbital has no radial node. Number of radial nodes in an orbital is equal to its n value, that is principal quantum number value, minus L value, that is azimuthal quantum number value, minus 1, that is n minus L minus 1. Therefore number of radial nodes in 3s orbital is equal to its n value is 3, L value is 0, minus 1, that is equal to 3 minus 1, which is equal to 2. Therefore for 3s orbital number of angular nodes is equal to 0 and radial nodes is equal to 2. Therefore here the answer is option number 1. Now question number 3. A particular station of All India Radio New Delhi broadcast on a frequency of 1368 kHz. The wavelength of the electromagnetic radiation emitted by the transmitter is, in brackets, speed of light c is equal to 3 into 10 raised to 8 meter per second. Option number 1 2192 meter, option number 2 21.92 centimeter, option number 3 219.3 meter, option number 4 291.2 meter. Here in this question, frequency of the radiation emitted nu is given, which is equal to 1368 kilohertz, which is equal to 1368 into 10 raised to 3 hertz or second raised to minus 1. Here the velocity of radiation c is given as 3 into 10 raised to 8 meter per second. We know wavelength of radiation lambda is equal to its velocity c divided by frequency nu. Here velocity c is equal to 3 into 10 raised to 8 meter per second and nu is 1368 into 10 raised to 3 second raised to minus 1. By calculating this, wavelength lambda is equal to 219.3 meter. So here the answer is option number 3. Now question number 4. Identify the incorrect statement from the following. Option number 1. The shapes of dxy, dyz and dzx orbitals are similar to each other, and dx square minus y square and dz square are similar to each other. Option number 2. All the 5D orbitals are different in size when compared to the respective 4D orbitals. Option number 3. All the 4D orbitals have shapes similar to the respective 3D orbitals. Option number 4. In an atom, all the 5 3D orbitals are equal in energy in free state. See here the answer is option number 1. Because in this statement, the first part, that is dxy, dyz and dzx orbitals are similar to each other, which is a correct statement because these 3 orbitals have double shape in which electron density is oriented in between the axis. But the second part of the statement, that is dx square minus y square and dz square are similar to each other, which is a wrong statement because dx square minus y square orbital has double shape in which electron density is oriented along x and y axis. This is the shape of dx square minus y square. And the shape of dz square is, here electron density is distributed along z axis and in the xy plane like this. That is, these 2 orbitals have different shape. Now we can analyze the other options also. The second option, all the 5D orbitals are different in size when compared to the respective 4D orbitals, which is a correct statement because 5D and 4D orbitals have different size because as principal quantum number value increases, size of orbital increases. See the option number 3. All the 5 4D orbitals have shapes similar to the respective 3D orbitals. We know 4D and 3D orbitals have identical shape. Therefore, it is a correct statement. In option number 4, in an atom, all the 5 3D orbitals are equal in energy in free state. This is also a correct statement. We know in D subshell, all the 5D orbitals have identical energy. Therefore, these orbitals are called degenerate orbitals.